So here's a video where we will simplify some trigonometric expressions. In each of these problems, it helps to have the fundamental identities just in your head. I will say that. So that's a good way to start when you're starting to work on these problems, is to work on just memorizing the ratio identities, reciprocal identities, Pythagorean identities, including their various forms. So this first one we want to simplify is secant theta times cotangent theta times sine theta. So starting out, having the reciprocal identities in your head will help it occur to you to turn this secant theta into 1 over cosine theta. And cotangent, using the ratio identity, is equal to cosine over sine. Oops, this blue marker isn't so good. And then just sine theta, leave that alone. All right, well, now we notice, well, there's a cosine in the numerator and the denominator. There's a sine in the numerator and denominator. And so all that's left of this is 1. And so that's pretty simple. But so we've simplified this product. Secant theta times cotangent theta times sine theta, turns out it's just equal to 1. All right, so moving on with this next example. Secant theta plus cosecant theta times cosine theta minus sine theta. So the first thing to do here is probably just to multiply it out. Use that old FOIL method from algebra. And so this is equal to, we could start with secant theta times cosine theta. And then outside, so this is secant theta times negative sine theta. So that's minus secant theta sine theta. Inside, you have cosecant theta times cosine, so I'll just write that positive cosecant times cosine. And then last, cosecant times negative sine, so that's overall that's negative cosecant theta times sine theta. Okay, that's a lot. But you should use the reciprocal identities at this point and turn secant theta into 1 over cosine theta. So this first piece is actually 1 over cosine times cosine, so this is just 1. Minus, all right, secant theta, which is 1 over cosine, times sine. So we'll do something with that in the next step. Plus, so cosecant is 1, that's the reciprocal of sine. Cosecant is 1 over sine times cosine. Minus, okay, cosecant is 1 over sine. This is just a lot of reciprocal identities at this point, times sine. So here the sine thetas cancel. And so let's see what we have. This is 1 in front. And then this, if you multiply straight across, is sine over cosine, which is equal to tangent. So now having the ratio identities in your head is helpful. So sine over cosine here, which is equal to tangent theta. And then here, this would be cosine theta over sine theta. So cosine over sine, that's equal to cotangent. This one's positive. And then the last piece here, the sines canceled, so that's minus 1. So what we could notice at this point is we have 1 minus 1, so that's 0 when you combine those constant terms. And so all that's left is this negative tangent, positive cotangent, which you could just leave it like that. I always like to have the positive term in front, so I would rewrite this as cotangent theta minus tangent theta. And there we go. So that's the simplified version of this product right here, which does look, quite a bit simpler. So here's 2 more examples. So first of all, we want to simplify this expression. So sine squared x over cosine squared x plus secant x times cosine x. So the first thing I would do here is, again, reciprocal identities. Turn this secant x here into 1 over cosine. So this is sine squared x. I'm leaving this part in front alone for now. Change the secant x right here to 1 over cosine x. And so now, and you might even look at this from the beginning. I have the reciprocal of cosine times cosine. I have 1 over cosine times cosine. So that product is just going to be 1. And it would be okay to turn this into a 1 without showing this step. Once that starts to click, in your head, that I have the reciprocal of secant, or reciprocal of cosine times cosine. So the product will just be 1. Okay, so now that we want to combine, let's say we want to combine these terms. So you have sine squared over cosine squared plus 1. I'll write it as 1 over 1. And we'd like to combine these terms, so we're going to need a common denominator. So what I could do here, I want a common denominator that's going to be cosine squared. Multiply the numerator and denominator times cosine squared. Then both of these denominators will now be cosine squared. So I can write a single fraction with cosine squared in the denominator. And the numerator will be sine squared plus cosine squared. So now is a good time to remember the Pythagorean identities. And there's a really important identity that says sine squared plus cosine squared right here is equal to 1. So this is equal to 1 over cosine squared. And since 1 over cosine is equal to secant, the 1 over cosine squared x is equal to secant squared x. That would be our fully simplified version of this expression here. Okay, and now one more example with this type of problem where we're simplifying. So we've got cotangent theta minus cosecant theta over cosecant theta times cotangent theta. So with this one, there's lots of cosecants and cotangents. There's a couple of ways you could approach this. So if you're thinking, I would change it to sines and cosines. That's one way to do it. Or, so make this like cosine theta over sine theta. This is 1 over sine, and so on. But something I would notice, I have common terms in the numerator and denominator. I cannot cancel cotangent theta right now because I don't have it factored out. If I'm going to cancel it, it's got to be part of a product in the numerator. It's got to be multiplied in the numerator and then divided in order to cancel, which is not what's happening here. But what you can do is separate. If you have addition or subtraction in the numerator of your fraction, you can separate this into individual fractions. So cotangent theta over that denominator minus cosecant theta over that denominator. And what I'm doing right now is kind of the opposite of what we did in this problem up here, where I got a common denominator. And I took these separate terms, combined it to a single fraction here by getting that common denominator of cosine squared. Here we're doing kind of the opposite. So it's combined as a single fraction. We're separating it out and then reducing these individual fractions. So here the cotangents cancel. Remember to leave a factor of 1 as a placeholder in that numerator. Here the cosecants cancel. Again, leave a numerator of 1. And so what's left is 1 over cosecant theta minus 1 over cotangent theta. And now it's nice to know your reciprocal identities. Well, 1 over cosecant, that's the reciprocal of cosecant, which is sine theta. And 1 over cotangent, that's the reciprocal of cotangent. Anytime you see 1 over something, read that as reciprocal of blank. So this is the reciprocal of cotangent, which is tangent. And this is a nice simplified final answer.